Hello and welcome to Maths with Mr Amison. In this video we're going to be practicing finding the probability of mutually exclusive events. That means events that happen independent from each other. If one event happens, the other cannot happen. For example, if it's raining, then it can't not be raining. If it's not raining, it can't be raining. They're mutually exclusive. Alright. First thing we're going to do is I'm going to show you an example. Then I'm going to talk through it, and after we've finished, then you should copy it down. So this isn't the only way to answer this question, but I want to talk through this because it's a good indication of how to do this when things get more difficult. So you can see there are 30 red counters out of the 100 counters in the bag, and there are yellow and blue counters in there as well. So if we have 30 out of 100 being red, that's 0.3 as a decimal, because probability can be written as fractions, decimals, or percentages. So if we have 0.3, then we know that the probability of all three events added together, because they're mutually exclusive, the probabilities of each one need to add up to 1. That's because it is certain that if I put my hand in this bag and take a counter, then I will pick one of those three colours. There aren't any other options. So the probabilities need to add up to 1. So the yellow and the blue probabilities together should add up to 0.3 less than 1. So if I take 0.3 away from 1, I get 0.7. So these two probabilities should add up to 0.7. Now, it says there are equal amounts of yellow and blue. So if there are equal amounts, then if I divide that 0.7 by 2, sharing the probability 0.7 equally between 2, then I get 0.35, which means that the probability of yellow and blue should both be 0.35. And if we do this with the actual counters themselves, 30 out of 100, that means that 70 out of 100 are not red, and therefore we must have 35 yellow and 35 blue. So we get probabilities of 35 over 100, or 0.35, and 35 over 100 for this one as well. So this is a good general way of doing this, because you're not always going to be given the total number of counters. You may just be given the probability and need to work from there. Alright, take some time to copy this down, and once you're done, have a go at this question on the right. Alright, so you've had some time to copy down and to have a go at this question. So there are 200 counters in this bag. 110 of them are red. So if I start to write this out, I've got 110 out of 200 being red. Now, that means that we have a probability of 0.55, which I can write in there. Decimals is just a little bit easier to work with when it comes to probabilities adding up to 1, because adding up fractions to 1 is a little bit trickier. So it's preferable to write real probabilities as decimals in these cases. Alright, there are twice as many yellow as blue. So if I do before I get onto that, let's take that 0.55 away from 1, because the yellow and the blue probability must now add up to 0.45. So if there are twice as many yellow as blue, then that means that I can do a bar like this, with yellow and blue, twice as many yellow as blue. You can see that splits this bar into 3 equal size pieces, which means if I share that probability, 0.45, into 3, that gives us the value of the probability of each piece, which means the probability for blue is 0.15. And if I multiply by 2, I get the probability of the yellow, because the yellow is 2 bars here, so I get a probability of 0.3. You can see that the probability of yellow is now twice as big as blue, and they add up to 0.45, and all of the probabilities in total add up to 1. So here are 6 questions for you to try. The first three are all fairly simple because the number of counters in total is given. Question 4, 5 and 6 are not given those things. Question 6 is a little trickier because the numbers are a little bit more complicated. Alright, so have a go, do your best. So here are the answers to those questions. Question 1, if we have 4 yellow, that means we have 6 that are not yellow. If there are equal amounts of red and blue, that 6 divided by 2 is 3. Therefore we have 3 red and 3 blue. So 3/10 red, 0.3, 4/10 yellow, 0.4, and 3/10 blue, 0.3. Question 2, we have 5 red out of 20. So that's 5 out of 20. That's 2.5 out of 10. So 0.25. And then we have 15 that are not red. So we have to have 15 in total, not red. If there are twice as many yellow as blue, that means we can split that 15 into 3, because for every 2 yellows there's 1 blue. So 15 divided by 3 is 5, which means there's 5 blue and 10 yellow. So 10/20ths yellow, that's 0.5, and 5/20ths blue, that's 0.25. For question 3, 5 red, so that's 5 out of 25, which is 0.2. Then there are 3 times as many yellow as blue, which means if there are, for every 3 yellows there's 1 blue. So that's 4 in total. So if we share the remaining 20 into 4, that means each part is worth 5. So the blues, there are 5 out of 25 blue, which is 0.2. And for yellow, there are 15 out of 25 yellow, which is 0.6. Question 4, we're not given the total number of counters in the bag, just that the probability of picking red is 0.2. If the probability of picking red is 0.2, that means the probability of yellow and blue combined must be 0.8. So if there are 4 times as many blue as yellow, 4 blues for every 1 yellow, that's 5 in total. So if we share that 0.8 by 5, we get 0.16. If there are 4 times as many blue as yellow, that means that yellow must have a probability of 0.16. Blue must be 4 times higher, so 0.64. And we can double check the answer there by adding up those probabilities. And you see that 0.64 add 0.16 add 0.2 does equal 1. If there's fruit in a fruit bag for question 5, 22% apples, that's 22 over 100, 0.22. And 2/5 are oranges, that's 4/10 or 0.4. That means because the probabilities need to add up to 1, if I take 0.22 and 0.4 away from 1, I end up with 0.38. Therefore, we have a probability of 0.38 for bananas. If a cafe is making 3 types of soup and 57% order tomato soup, that's 0.57, and equal numbers of customers order mushroom soup as minestrone soup, then that means that these two probabilities need to add up to this much less than 1. 1 take away 0.57 is 0.43. And then that 0.43 is shared equally between mushroom and minestrone. 0.43 divided by 2 is 0.215. Therefore we have a probability for both of them of 0.215. Alright, well thanks for listening, thanks for watching. Hope you found it useful. Speak to you again soon.